All that we do is touched with ocean, yet we remain on the shore of what we know. "4 billion years ago, as the molten Earth cooled, a vast world ocean was formed. This sea became the cradle of life on Earth.
Tomorrow's rain will wash the stains away. Something in our minds will always stay.
The ocean averages 2 miles in depth and is filled with life. The underwater world supports life forms in a far wider diversity of shapes and colors than exist on land.
On and on the rain will fall like tears from a star, like tears from a star. On and on the rain will say how fragile we are, how fragile we are, how fragile we are, how fragile we are.
The ocean encompasses creatures as delicate as the jellyfish or as powerful as the whale. Somehow they all fit together, and we're just beginning to understand how. Our growing knowledge is important. We can't protect what we don't understand. We live because the sea lives.
Here, in the islands of Palau, the rhythm of our life is the rhythm of the sea. We are born on a certain tide, we die on another. The tide carries our boats out to the fish. It brings us back to feed our families. The seasons of our lives depend on different currents that guide us to the schools of feeding fish.
Ocean currents caused by winds and the Earth's rotation circle the globe, linking what we once thought were many separate seas. We now realize there is only one ocean, the world ocean. The waters of the world ocean wash the warm volcanic coastline of Hawaii. These same waters lap against the frozen inlets of Alaska. And pulse through the Red Sea between Africa and the Arabian Peninsula. These world currents also nourish the giant kelp of California, which can grow a foot or more in a single day. The world's aquatic plants, including kelp, provide 70% of the oxygen we breathe. The world ocean is a single interconnected system. For example, one current flows halfway across the world from Australia past Africa, then joins the Gulf Stream in the North Atlantic. Just as currents move the waters of the world ocean, so do the tides, which ebb and flow under the gravitational pull of the moon. High tides follow the moon as it orbits the Earth. Canada's Bay of Fundy on the Atlantic coast is famous for its immense tidal flow. Up to 1 trillion tons of water enter and leave the bay with each tide. High tides can reach 50 feet and more. Low tides empty coastal channels, leaving veins of red mud. The tides enrich the land enriches the sea. While the moon's gravity tugs the world ocean to a depth of 1,000 feet, winds churn its surface. Ocean waves driven outward from fierce storm centers often travel for a week or more until they explode against the land. Large waves, moving at speeds of up to 70 miles an hour, surge across thousands of miles of open ocean.
Port bow! Port bow! Right behind it. That's gonna push, it's gonna push.
When these waves approach the coast of Oregon at Cape Disappointment, they keep the United States Coast Guard busy. Here, they teach heavy surf rescue.
First thing cadets learn in this school is humility. In the past 2 centuries, over 1,000 vessels have been lost here at Cape Disappointment. When waves are small, Oscar, our search and rescue dummy, likes to take a swim.
All right. Man overboard! Starboard side! Daryl, you got my pointer. All right. Starboard side, understand. Stand by. We'll be coming around when I get a hole. All right. 2 waves, make it in front.
Search and rescue drill in calm water is no problem, but we need to be able to rescue boaters in 15-foot seas. That's tough work. A single 15-foot wave can drop 200 tons of water on a boat.
Hold the Widowmaker. One right behind it. Get one for the next one.
The ocean's size and power dominate our planet. For centuries, sailors feared its destructive force. Today, surfers meet it at the point of its greatest fury where they find themselves mysteriously at home.
You're riding these waves that have traveled thousands and thousands of miles.
You know, you're at the mercy of the ocean. You're underneath those waves, and you hear the rocks rolling around on the ocean floor. You hear the thundering of the waves. You know, it's just amazing. You know, it'd be great just from underneath the waves forever.
There is a deep purpose rising in the world. There is no deeper purpose. Listen to me, girl.
Despite its great power, the sea invites contemplation. What is our place beside the immensity of the ocean?
All colors bleed to red. Sleep on the ocean's bed. Drifting in empty seas. For all my days remaining. Would north be true?
Well, for me, the ocean's always had special significance just because you're so close to nature. There's so much life around you under the ocean. There's fish, and there's dolphins, and there's whales, and there's sharks, and there's, you know, heaven knows what else swimming around and under you all the time. And there's certain moments, especially where you feel as one, you sort of melt in and you really do feel a part of the ocean, which is a great feeling, but you have to look for that now, where I'm sure a long time ago that was a natural part of being an ocean person.
Dark angels follow me over mountains of endless falling. For all my days remain. Why should I cry? Why should I cry?
Our relationship with the sea is seldom very deep. Most of our contact with it takes place on the surface. We are drawn to the ocean, but how do our ever-increasing numbers threaten the health of the living sea? To find out, we need to look beneath the surface. Scientists at the Monterey Bay Aquarium Research Institute use remote control submersibles to study the ocean and monitor our impact on it.
We call it an ROV, but officially, it's a remotely operated vehicle. It's the underwater equivalent of a NASA space probe.
The Deep Sea Project Chief is oceanographer Bruce Robeson.
Release made. Bruce, you want to get the tape deck and the CTD, please? Connor, can you fire the sonar, please? Okay. Ship's heading. On ship's head.
Vehicle heading 189. Vehicle depth 30 feet. Moving down.
As the ROV descends to 1,500 feet, it enters the world I love. While we stay in the mothership up on the surface, the ROV dives, sending us back live video pictures. On many dives, we find species never before seen by anyone.
Now at 1,500 feet.
Is that same species that you and George described?
I think so, but we're looking at it on the side, so it appears to have a different configuration.
Here, let me put it on a bigger monitor.
Hey, what is this showing up on the sonar screen?
On this particular dive, our sonar locked onto something big, about half the length of a football field. It was the first time we'd seen this type of siphonophore. We moved in on its head.
Look at the detail of that head.
You can see how the swimming valves pulse, the valves close after the thrust so that water doesn't go back inside.
The siphonophore is one of the most remarkable animals on Earth. It sounds like science fiction, but it's not. It's actually made up of hundreds of separate, specialized individuals.
That's great, that's perfect.
The swimming bells are separate units. So are the stomachs. So are the reproductive sections.
You're going to want to run the length of this?
Yep, as soon as we get some shots up the bell.
Here, I'll move.
The animal is so huge, it's hard to imagine all these individual units working together.
You want me to stay with the head, Bruce?
Yeah, let's stay at this end of it for the time being, Jim.
How many other creatures are there like the siphonophore?
I think it's been down here.
And what do they tell us about the vitality of the sea?
The source of food at this depth.
The mid-ocean level is enormous, and we've only studied a small fraction of its volume. We've still got a lot of work to do.
All over the world, scientists are finding evidence of the connections that link the living sea. What we do in one place affects the entire ocean. Off San Diego, oceanographers are studying the impact of pollution on the kelp forests, which are nurseries for spawning fish. In the Central Pacific, giant clams, some weighing 400 pounds, faced extinction from overharvesting. Scientists then studied the clam's spawning cycle. An adult clam is both a male and a female. It releases millions of tiny eggs and then even more sperm. Today, using simple techniques, scientists can make clams spawn. They now produce over 1 million seed clams a year. Here at the Monterey Bay Aquarium in Central California, sea otters that have lost their parents bond with a human trainer.
I try to teach the baby otter to hunt for food. It begins to think of me as its mother. And after a year, it's hard for me when we return the baby otter to its own home, the open ocean.
Like the sea otter, the humpback whale was once hunted nearly to extinction. In Bar Harbor, Maine, Dr. Steve Katona leads a team studying the humpback. The underside of a humpback's fluke is like a fingerprint. No two have the same markings. That's what allows Steve Katona to track them.
The first time a whale is photographed, it's given a name and number, which we share with other research stations all over the Atlantic Ocean. By matching our photos with other sightings, we follow the whale's migrations.
Yeah, close, but not it.
Wrong pattern.
Nope. Hold it. The markings check out.
This is it.
Badge. What a great name.
Once we identify the whales, we can count them. There's no question that restrictions on hunting are working. There are now over 12,000 worldwide, and the population is growing.
The expanding population of humpbacks is a measure of our growing love for the sea. On one isolated group of islands, that same wisdom, that same love is called tradition. The remote island chain of Palau, located near the equator, east of the Philippines, gives scientists a rare look at a vanishing underwater world. These waters may contain more species of marine life than any other place on Earth. Historically, Palau has had little contact with the outside world. Palauans still maintain their tradition of profound respect for the sea.
For 3,000 years, our ancestors lived in harmony with the sea, never taking more than they needed. Each family group worked a patch of reef. They tended this reef like a garden. I'm Francis Torrevillon. Although he's old now, my father still swims the reefs with me. Our waters are protected by a barrier reef. That's one reason we have so many fish, so much life here. I was born by the sea. When I was a boy, I had fun carving storyboards. After the old men would teach us an ancient legend, we try to bring the story to life in a piece of wood. This one is about how these islands came to be. All the stories are about our long ago people. We are islanders and our lives are of the sea. I think sometimes the traditional ways are still the best. Even today, my children have one foot in the old world and one foot in the new. I try to teach the old ways to my daughter Julie and my son Wes. It's okay with me if they like speedboats, as long as they respect the sea. Today, I'm taking my children to an island they have never seen before. We have over 200 rock islands in our waters. We call them floating gardens. Mostly, we do scuba for fun, but also it's a kind of courtship. I hope my children will fall in love with the sea. We are lucky today. This is the first time my children have seen a cuttlefish. The cuttlefish is very shy and quite intelligent. It can change its spots to communicate with other cuttlefish, or it can change color for camouflage. Since it's a type of squid, the cuttlefish can also release a thick cloud of ink. That's why we don't want to get too close. Coral looks like a plant, but it's really an animal. When coral dies, it becomes like rock, and new coral grows on top of the old skeleton. Coral reefs are always growing. They're the largest structures made by any living thing, even by us. We know that what happens in other parts of the sea touches our waters. Far away, big factory fishing boats net many groupers and tuna. Now, we seldom see these fish along our reef. It's all one ocean. This is what I'm teaching my children today. Scientists also like to come here to learn. They say our coral reefs, our fish, and our marine lakes still hold secrets.
We're flying south from the main island to one of the most bizarre and potentially dangerous dive sites in all Palau. With me is marine biologist Bill Hamner and his wife Peggy. My name is Laura Martin. I'll be here for 5 years studying one of the strangest creatures in all the islands. It lives here in this landlocked saltwater lake.
The line!
We're studying this lake, oddly enough, to learn more about the world ocean. At the end of the last ice age, as sea level rose, saltwater filled the lake. Because it's small and enclosed, what we call a closed system, the lake is like a test tube for scientific study. Ocean species have been trapped in this saltwater lake for thousands of years. Today's my first visit, and I'm a little nervous. Swimming into a mass of 1 million jellyfish, you kind of expect to get stung, but you don't. These jellies have lost their need to sting. Each morning, over 1 million jellies gather and travel together across the lake, swimming almost a mile a day. They follow the same path and the same schedule every day. You could set your watch by it. Yet, here's an organism which has no eyes, no brain, following a complex migration pattern. How do they do this? These jellyfish follow the sun because inside their bodies, each one maintains a crop of algae, which is its sole source of food. It's roughly equivalent to carrying around a portable vegetable garden. The algae need sunlight to grow. Most jellyfish are hunters, stinging their prey before they eat them. These jellies are farmers with no need to sting. We found that there are 3 distinct depth layers in the lake. The top layer is like seawater. The middle layer is thick with red bacteria. Below that is a highly toxic layer. At night, the jellies descend to this nitrogen-rich bottom layer of the lake to fertilize their internal gardens. As we descend into the poisonous layer to take samples, hydrogen sulfide begins to enter my bloodstream through the skin, excluding oxygen almost immediately. A wetsuit is no protection. If we were down here 5 minutes, it could be fatal. We only stay 45 seconds.
These jellyfish, which Laura Martin will study for the next 5 years, have shown a remarkable ability to adapt. They have lived for millions of centuries, since before the time of the dinosaurs. Yet they are among the most fragile creatures on Earth. The ocean encompasses creatures as delicate as the jellyfish or as powerful as the whale. Somehow they all fit together, and we're just beginning to understand how. Our growing knowledge is important. We can't protect what we don't understand. What we understand most profoundly, we love.
Here, in the islands of Palau, respect for the sea is passed down from mother to daughter, from father to son. It is carved into our storyboards. A woman once had a baby girl, the board says. The child grew so large that she fell into the sea. The parts of her body that poked up above the surface became our islands of Palau. I love this story because it tells me that our lives and the life of the sea are all of one piece, braided together. Here we are islanders. We live because the sea lives.
It really means a lot to me that these huge and beautiful creatures, which came so close to extinction, are on their way back. Whale populations are a yardstick I use to gauge the health of the ocean. By that measure, I think we have reason to hope.
Our efforts to sustain the life of the sea have made a difference. Yet, scientists have shown us that the ocean environment is much more fragile than we ever thought. Because the land we live upon occupies only a fraction of the Earth's surface, we are all islanders, no matter where we live. For rain, for food, even for the air we breathe, we all depend on the health of the ocean. All life on Earth is a celebration of the living sea.
We'll have Oscar aboard in 20 seconds.
Copy that. Keep up the good work.